These are the 4.1 notes, and we're going to be looking at sampling and surveys. So the first thing that we need to understand is the difference between a population, a census, and a sample. The population in a statistical study is the entire group of individuals we want information about. A census collects data from every individual in the population. So the easiest thing to think about is the U.S. Census, where they go through, they try to figure out the exact population of the United States. They try to get as much information about that exact population as possible. Now, obviously, this is something that doesn't happen often. United States is roughly like 330 million people. The census takes place once every decade, so once every 10 years. It takes an enormous amount of planning, it takes an enormous amount of advertising, it takes an enormous amount of work to get everyone to respond to the census survey. There's legal rules, there's a bunch of things going on to make the census happen. It's really, really hard to get the entire group of the population to respond to a survey. That's why when we think about the census in the United States, it only happens once every 10 years. It's kind of a fairly rare event. Every person is only going to get like 10 or 11 censuses max in their lifetime, and it's going to be more along the lines of, at the current life expectancy in the United States, 7 censuses for the United States in your lifetime that you'll see. So doesn't happen that often. It's hard to make happen. A sample is a subset of the individuals in the population which we actually want to collect data. So population is the whole group, sample is a group within the population. So let's say that as opposed to the census of the United States citizens, they just went through and went to like every 10th house. Then 10% of the citizenry becomes the sample size. Or let's say that they just chose some citizens at random. However many citizens they choose, however many they get, that's your sample. A sample survey is a survey which is organized to use a sample that represents the specific population we want to observe. So again, if we're talking about the U.S. population, we're going to try to create a sample that represents the U.S. population in some way, shape, or form, and then ask them questions. So when we think about like polling data, we're hearing that all the time right now with the election coming up. Polling data is done with sample surveys. They're trying their best to get samples that represent populations and then go from there. And then even within polling data, we can break it down. When you have a national poll, that means your population is the entire population of voting age adults in the United States. And then your sample size is however many people you're asking, the people that you're asking about for that represent kind of the United States as a whole. State, and then we break that down. You can have a state poll, which represents the population of the state, voting age adults in the state, and then your sample is the people that you called within that state. So we can break this down on a national level, a state level. Populations can be big or small. It all depends on how we define what our population is. So when we're looking at the state poll of Wisconsin for the presidential election, our population is voting age adults in Wisconsin. Our sample is who they called, who they asked for to get their polling data. All right. So types of generally bad samples. Choosing individuals from the population who are easy to reach is a convenient sample. So let's go back to polling. Let's say that we wanted a Wisconsin state poll, so they just went through and they drove to, the people who are doing this left their house, they walked down the street, they live in like Wausau, and they just asked the first 100 people in Wausau they see. That's a convenient sample. This is a generally bad sample. Obviously, like Wausau might have different political opinions than Racine, which might have different political opinions than Madison, which might have different political opinions than Rhinelander. So that convenient sample is not going to be super representative of the entire population of Wisconsin. It was very convenient for this person who lives in Wausau to get that opinion. The design of a statistical study shows bias if you consistently underestimate or consistently overestimate the value you want to know. So if we're doing a poll and we're doing our poll only in Wausau, we're underestimating. We don't get any of the opinions of Racine, Kenosha, Rhinelander, Green Bay, Madison, Milwaukee, Marinette. We don't get any of those opinions from any of those people. We've underestimated their role and we've overestimated Wausauians in that poll. A voluntary response sample consists of people who choose themselves by responding to a general invitation. So, easiest example I can think of. You go to a fast food restaurant these days, How many times do you walk away and they say, here's a link, they circle something at the bottom of the receipt, they say, here's a link to a survey, if you complete the survey you get a free soda or you get a free hamburger or whatever. I think I've gotten those 300 times in my life and I've never done a single survey. A voluntary response survey is going to be based on, okay, they got that receipt, you're being told you can go to this website to fill out the survey, they go to the website and fill out the survey. The fast food restaurant is obviously trying to incentivize it to try to get more people to do it. They figure if they offer free food, maybe more people will participate. But that voluntary response survey is still voluntary. It's not mandatory. It's not forced in any way. People can choose to do it. People can choose not to do it. So that ends up being a pretty bad survey too, because you usually get people who are pretty passionate. Either somebody who really wants to rant about how bad the service was, or somebody who may really enjoy your burgers. So if you're offering a free food or a free drink to complete the survey, they're really passionate about getting free stuff. So they're the ones who are completing it. You're not getting a total idea of what's going on. All right, so we got to check for understanding here. The farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. So identify the sampling method to use. That's a convenience sample. He just chose the first 10 he saw. And then how could this be biased? Well, if we're thinking about a crate of oranges, if you're inspecting the ones at the top, maybe the oranges at the bottom are not doing so well because they've got all these oranges on top of them. Maybe they are being compressed. Maybe they're being maybe they've got some mold on them. Who knows how long they've been in that crate, etc. If you're only looking at the top 10, you're not getting a good idea of what the entire crate looks like. There's a million things that could happen to oranges at the bottom of the crate, and you don't know what's going on if you're only pulling from the top. All right, the ABC program Nightline once asked whether the United States should continue to have its headquarters, or the United Nations should continue to have its headquarters in the United States. Viewers were invited to call the telephone number and respond yes and another no. There was a charge for calling either number. More than 186,000 callers responded, and 67% said no. This is a voluntary response survey, and not only is it voluntary response, it's voluntary response with a charge in order to do the survey. You're probably going to end up with only people who are extremely passionate about this concept. So for whatever reason, in this case, we've got a group of people who feel very strongly that the headquarters should not be in the United States, but since it's voluntary response and there's a barrier of some cost inhibiting factor that would allow some people to respond and others not to, you're going to end up with a biased survey. You're going to get a certain group of people who are very passionate about this and have the income in order to respond to the survey respond. So it's not giving you a true representation of what U.S. citizens feel like. You're getting a representation of people who watch Nightline, who feel passionate, who will call in and will pay to call in order to give their opinion. All right, so then types of some generally good sampling is random. A random sample involves using a chance process to determine which members of a population are included in the sample. So very commonly, the easiest one that they always talk about is pulling names out of a hat. If we just put every name from the, like if we wanted to sample 5 members of the upper school, we would put every single upper schooler's name in a hat. We would draw them at random, and then those 5 would be the ones who would respond. A simple random survey of a size n is chosen in such a way that every group of n individuals in a population has an equal chance of being selected to the sample. So again, let's say that we want to do a sample of upper school students, and I'm going to use this number 12 because this is going to be very helpful to us. We've got 12 kids that we want to sample, so we put every single name in a hat, pull them all out, and we say to ourselves, all right, cool, this is our sample. That every kid had an equal chance of being chosen from that hat. The sample, the survey that we're choosing is just those 12, and that's what it is. All right, random numbers to assign a sample. So a very simple way to help ensure an SRS is to assign each individual of the population we are trying to get data from, assign them a number, and then use a random number generator for the respondents we choose. I will show you how to use your calculator for this. In the real world, you always use a random number generator. You will use a TI-83 calculator. You'll use Excel. You can go to Google, type in random number generator, and it will do it for you. And that's the real world way of random number generators. There's a million out there. They're easy to find. They're all over the internet. You have them on your calculator. You can download an app on your phone for it. Every analysis program has it. Every software program has it. it's in Excel, it's in Google Sheets. Random number generators are everywhere. However, we do need to know how to use the random number chart. This is because, and think about it, for the AP exam, if they want to ask a multiple choice question about you randomly assigning people, you can't use a random number generator because everyone's calculator is going to give different random numbers. So what they have to do is they have to give you a chart, and they have to see if you know how to use a random number chart in order to randomly assign samples. I don't like it, but I understand why they do it. This is one of the few times I can say, like, okay, this makes sense why the technology, like, even though it's used 99% of the time in the real world, we might want to use that chart. The random sampling chart was very useful prior to the idea of having a random number generator that could help us, but with the random number generator, we'll use that all the time. But I am going to show you how to use the random number table. So this is in the back of your book. This is the entire table. You also have this photo now. This is table D. It's random digits. So here's how we use it. Using a table to conduct a simple random sample. So Susie Q is a student at Anywhere High School. Anywhere High has a popular group of boys who go by the moniker the Johnnies, due to the fact that all 26 of them are named Johnny. They are extra special as each one has a last name starting with a different letter, with each letter of the alphabet represented. Susie Q is conducting a poll for the school newspaper. She wants to conduct an SRS of the Johnny's favorite fast food restaurant. She determines 6 Johnnies will be enough. Anywhere High is well known for their total no technology policy, so Susie will have to use a random table to find the participants. If she starts on the line 106, which Johnnies will she end up choosing for the survey? So what I'm going to do here is I'm going to assign the Johnnies 01 through 26 because we've got 26 of them, and we've got Johnny A, Johnny B, Johnny C, all the way through Johnny Z. I can know here I'm going to work in alphabetical order of their last names. Johnny A will be 01, Johnny B will be 02, Johnny C will be 03, all the way up until Johnny Y is 25, and Johnny Z is 26. So now what I do is I'm looking for 6 of them. I'm going to go up to my table. I'm going to go up to line 106. I'm going to look. I've got 68. That's beyond 26. Doesn't work. 41. Beyond 26. Doesn't work. 73. Beyond 26. Doesn't work. 50. Beyond 26. Doesn't work. 13. That works. So now I know that Johnny M will be one of them. So we've got, I need 5 more. I've done 13. 15, perfect. So that means M, N, O. So we've got Johnny O. $52, too big. $97, too big. $27, too big. $65, too big. $85, too big. $08, perfect. A, B, C, D, E, F, G, H. We've got Johnny H. I go back up. 95, 70, 76, 50, 21, finally. So Y is 25, X is 24, W. So this would be Johnny V. And I'm going to stop at 4, even though we could go on to 6. We get the point at this point. So you go through, you look at every 2 digits in that line. Digits that are too big, you just skip and you move on until you get digits that work. Don't try to force things. Don't try to repeat numbers. You're going to be given a line to start with, and you go through. If we're designing multiple studies and we're using random numbers, we would use a different line to start with every time. You want to keep randomizing it. If you use the same line every time, it's no longer random because it's the same pattern. Obviously, this table never changes. So if we don't change based on that, we'll never end up with it. So that's how I would go through and do it. Obviously, we need 2 more here, but that's how we would go through and use our random number table to assign people to a group. All right, so there's other random sampling methods. There's strata, which is groups within a population classified by similar individuals. Now, this can change however we want it to be changed. So we think about let's think about Prairie again. Let's think about our school. So I can use grades as a strata. I can use 9th, 10th, 11th, and 12th grades as a strata. We're going to say there's some similarity between freshmen that might not exist between seniors. I could use where you live. We could talk about Oak Creek, Kenosha, Racine as strata. Like, what city do our students live in as a strata? We could talk about boys and girls as a strata. We could talk about different genders as a strata. We could talk about modes of transportation to the school, bus, drives themselves, riders, etc. We can do all these different things as strata. We can use any qualification we want as strata. And it's going to be important if we think a strata might define something. So if we're asking about like college choice, we're probably going to talk about strata in terms of what grade you're in, because your college choice is going to evolve throughout high school based on what interests you have, what their majors are, what your grades end up being, etc. If we're talking about habits you have in your commute to school, we're probably going to define it based off of either like how you get to school or B, where you live. So like for me, my habits getting to school when I live 3 minutes away are going to be much different than somebody who lives in Oak Creek who might spend 25 minutes on the road. We're going to define the strata differently based off of how we think it might impact it. A stratified random sample is a random sample where a simple random sample is chosen within strata and then of equal sizes. The strata don't necessarily need to be of equal sizes, but you want to have a proportionate representation. So if I want 12 students' opinion from the upper school and we've got a stratified random sample, I'm going to choose 3 kids from each grade, so that way I've got 4 grades, 3 kids from each. That's going to help give me a representation from each grade. If we've got wildly different values, we want to try to be proportionate with that stratified random sample. It helps if our strata are equal sizes. It helps so that way we can just choose equal amounts of students from each strata. But obviously how you define your strata might change sizes, so you're going to try to be as proportionate as possible. So that way you get like the entire goal here is to get something that represents the population. And for the sake of our class, we're going to assume for the most part strata are pretty similar in size. We're going to assume that like every grade at Prairie is the same number of kids. We'll assume most high schools have similar grades, but like if we were talking about strata where one strata had a group of 40, another strata had a group of 20, and we were looking for 3 respondents, we'd probably choose 2 kids from the strata of 40 and 1 from the strata of 20. But the closer you can get to equal sizes, the better it is, because again, we're trying to get a total population idea here. We're trying to infer from the total population. So the closer we have to equal strata sizes and then equal respondents from those strata sizes is important. But at the end of the day, keeping your number of people chosen from your strata proportional to the number of people in the strata relative to the entire population is a big deal as well. A cluster sample is a little bit easier. This is dividing the population into groups based on individuals located near each other. So for example, at Prairie, if we were just looking for samples of people 10 through 12, we're just going to go to advisories. If we wanted the opinion of upper schoolers 10 through 12, we'll go to an advisory that gives us a pretty diverse group of people. Every advisory is probably going to have kids from multiple cities. It's probably going to have kids from multiple grades, kids with different interests. That gives us, we're going to be able to kind of infer the general population of Prairie from one advisory or multiple advisories. In like a sports arena, you might choose like one diagonal section, so like section 001, section 201, section 301, 401. Like you're just choosing one little group of the stadium. As you get further from the court or from the field, tickets are going to drop in price. So choosing like one specific section and then going all the way up vertically, that would be a cluster there because you're just looking at one section. It's easy to access. You're trying to get everyone's opinion there. That's an example of a cluster sample. And then you randomly choose which cluster. So you're not always going to go to the same cluster. You're going to assign each cluster a random number, use that random number generator, or like you put each cluster name into a hat, pull out the clusters you want out of a hat. You're basically conducting a simple random survey, but as opposed to choosing individuals, you're choosing entire groups to go for. It's important we know the difference between a cluster versus strata. A cluster is just a group of individuals who are located near each other, so it's representing the population and the idea that like each cluster kind of has total representation. If we think about an advisory, the advisory is a cluster because we have students from all grades. They could be from anywhere, etc. Strata is like something very specific, and we're going to choose a certain number from each strata to try to then create that representation ourselves. So grade levels of great strata at Prairie, they're fairly equal sizes. So if we're trying to get a survey of opinion of upper schoolers, we can choose the same number of kids from each strata. We've created this fairly arbitrary but maybe meaningful difference in kids to get opinions, so we'll break that down. You think about honor committee. Honor committee is kind of a good idea of what a strata is. It's kids 10 through 12 for academic integrity and what their opinion is on it. It's not chosen randomly, not at all, so that's not a random strata, but it is a good representation of how we would use strata. We try to get an equal number of kids from each grade to go into our honor committee and give their opinion to kind of represent the upper school. Now, it's not random at all, but it is a good idea of how we use strata. All right, so check for understanding. The manager of a sports arena wants to learn more about the financial status of the people who are attending an NBA basketball game. He would like to give a survey representative sample of the more than 20,000 fans in attendance. Ticket prices for the game vary a great deal. Seats near the court cost over $100 each, while seats in the top row cost around $25 each. The arena is divided into 30 number sections from 101 to 130. Each section has rows of seats labeled with letters A to ZZ. Why is it going to be difficult to give a survey? Survey a simple random sample of 200 fans. If you just assign each seat number a random number and then choose random numbers and then go find those random numbers, who knows if those people are going to show up? Who knows if they're in the bathroom? Who knows if they're going to the concession stand? You're going to have to hunt them down. You're going to have to fight through rows, etc. It's going to be hard to get the 200 people out of 20,000, especially when a number that large in such a variable event like that. So I'm using a little bit of real world understanding of what this arena looks like to help explain why just choosing 200 random seats and then going to those 200 random seats is going to work. Which would be better to take a stratified random sample of fans using the lettered rows in the numbered section as stratas. It's going to be rows to for stratified because if we're looking for the financial status, it's going to make more sense to break it down based off rows, where close rows are more expensive, farther rows are cheaper. We're going to try to choose an equal number of people from each row to get an idea of what the financial status is. So we're choosing from people who are paying less money to people who are paying more money, and we're setting those rows as your strata. If we're looking for cluster, the cluster is going to be based in the section. Each section will have all those rows, and within that section we've got rows from A, which are expensive, to ZZ. It's going to give us kind of a representation of the entire population. People who are paying a lot for tickets, people who aren't paying much for tickets. So cluster and stratified samples are going to be easier. You know which rows you're going to. I'd say in this case a cluster sample is going to be the easiest. You just go to one section, you hand out surveys to every person in that section. You're going to probably do a pretty good job of mixing up rows and get something that's representative of the entire population. All right, so rules of random sampling. We use random sampling for inference, i.e. we're trying to infer the information about the population from the sample. We use a random sample because it's more likely to avoid bias from the sample. When we say we're inferring, we're trying to make some estimations here. We can never say anything for certain. A random sample never allows us to say the entire population thinks this way because of XYZ. So again, easy example, 2016, you think of all the polling data that was going into the presidential election. The polling data is somewhat of a random sample when they're choosing who to call. They used all of that to infer, this is how we think the vote's going to go, and the vote did not match the polls whatsoever. The polls had Donald Trump losing the election, and he won the election. So that random sample, yes, it existed, but we couldn't infer from the entire population. We could make some good guesses, but there was a margin of error there because we're not getting the opinion of everyone. The only time that we can say everyone feels this way is when we have everyone responding. When conducting a survey, remember the larger a random sample, the better the information. So if those polls had 90% of voters, we'd probably have a much better idea of how that election would have turned out than when the polls can only get 5 or 6% of voters. They do their best to try to get every voter represented and things like that, but still each individual has their own opinion. It can vary and it can change. So we can't look at our sample and then say, because our sample feels this way, the entire population feels this way. Now, what can go wrong in surveys? Undercoverage, that's the biggest one. So some members of the population can't be found. Let's say that we ran a survey in the upper school the day we gave the PSAT. Well, we're not getting any of the juniors' opinion. They're completely undercovered. Let's say that we're running a survey of the first people who walk into school, the students who set their alarm for 8:10. We're not getting their opinion. They're undercovered. Non-response occurs when an individual chose for the sample, can't be contacted, or refuses to participate. So again, non-response is very common. We might start getting to a point where we start factoring in non-response. When I got to college, every single paper I read that had a survey had to write the number of people who didn't respond. It is an important part when we're actually doing academic research of writing down the number of non-responses. And non-responses are frequent. So we go back and we think about me talking about that fast food survey. They hand me a receipt. They say, fill out the survey for a free burger. I still never do it. I never have. I might at one point, if I ever get a better deal offered, if I'm just feeling lazy, I always say to myself, I will, but I never do. So I'm a non-response. They've offered me the survey, but I haven't done it. Inaccurate responses. So sometimes people fill out a survey and they write things wrong. That could be because there was confusion about the question. They might not have been able to understand what the question was asking. They might have made a mistake, so maybe they meant to, maybe it's a multiple choice. They meant to bubble in C, but they actually bubbled in B. And then sometimes it's outright lying. I remember when I was in high school, there was a substance abuse program that came through. They gave us an anonymous survey to fill out, and then because it was anonymous, a lot of kids made jokes. And it came back 2 or 3 weeks later that 14% of my school was using meth. 14% of my school was not using meth. I don't think a single member of my school had ever even seen meth, but very quickly our principal realized how much of a joke it was. They were trying to use it to just get a gauge on teenage drinking, but obviously this program wanted to know everything. And then so suddenly they had to throw out the entire survey. I don't know if they paid for it, but I do remember my principal being very upset. We had an entire assembly telling us that we should have taken it more seriously and how we just wasted a bunch of time and a bunch of energy. When you have 14% of students saying they used meth, 30% saying they used heroin, 25%, etc. It went on and on and on. We were trying to get an actual real look at what's going on, but so many people just did a joke because they thought it was funny. And that's what ended up happening. And then finally, the wording of questions can influence the survey. So a confusing question might lead somebody to answer the wrong way. They might not understand what was being asked, and that could be a mistake. Other ways can just be very, very leading questions. So again, I'm not trying to be political here. I'm not trying to give political opinion, so I'll do one both ways. Let's say with the Supreme Court nomination that's happening right now with Amy Coney Barrett, let's say that you got a question that said, 4 years ago, Republicans said during an election year, Supreme Court justices shouldn't be chosen. Do you think Amy Coney Barrett should be nominated right now? So they're giving you information on a past event to try to get your opinion that might sway your opinion because you're thinking about that happening then. Versus another example to go the opposite way, just to not be super political here. Let's say that we were given a question that Democrats have said that they might pack the court if Amy Coney Barrett is elected during this year. Do you think that packing the court is constitutionally invalid? So they're putting things that tend to be emotionally charged in front of the question. They're wording the question. They're giving background information to the question. A much more appropriate question would just be, do you think Amy Coney Barrett should be confirmed? Do you think that court packing should be allowed? Those two questions are less misleading. They're not giving you this information. They're not trying to put an obvious tilt on it. They're not trying to put a political party associated with it that might make you bring up these feelings. But really quickly, we can write questions in a way that make people respond a certain way. Some people are just going to respond however they think their political party might go, regardless of how the question is worded, if the question is worded in a way that supports their party. So that's something very common, happens a lot. We have to be careful with how we ask questions to try to get the most honest response and not a response that's been led. All right, so check for understanding. Each of the following is a possible source of bias in a sample survey. Name the type of bias that could result. So the sample is chosen at random from a telephone directory. Telephone directories are optional. My entire life growing up, my mom didn't have our phone number in the telephone directory. So you're underrepresenting the population because you only have people A, who have phones, and then B, people who are willing to list their name in the phones. Some people cannot be contacted in 5 calls. This is a non-response. Interviewers choose people by walking on the sidewalk to interview. This is a convenient sample. They're just picking people up off of the internet. And that bias is going to just be from people who tend to walk. You might not get people who drive cars, people who ride bikes, people who run, etc. Number 2, a survey paid for makers of disposable diapers found that 84% of the sample opposed banning of disposable diapers. Here's the actual question. It is estimated that diapers account for less than 2% of trash in today's landfill. In contrast, beverage containers, third-class mail, and yard waste estimated to account for 21% of trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? So they're giving a lot of background information. If you were just to ask, should we ban disposable diapers, and not giving the other information around it, you might get a different answer. So this here is like leading people to try to say that banning disposable diapers doesn't matter because they don't even create that much waste. It's not getting their actual opinion. It's just kind of shoehorning them into opinion. You can tell they want them to say that they're not in favor of banning it by giving other excess information. All right, you have a homework assignment tonight. Reach out with any questions or concerns, and have a great night.